Alright, today we're looking at differential equations and slope fields. All a differential equation is some equation that has a derivative as well as x's and possibly y's as well. So here's an example of one, and all this dy dx, this is a derivative. This is telling us a slope. It means slope at any given point can be given by this equation, x plus x times y, which means I just need to plug in my x and y values to be able to get what my slope is. So if I plug in 2 for x and 1 for y, 2 plus 2 times 1, which is 4. That means at the point 2 comma 1, I have a slope of a tangent line of 4. Same thing, if I plug in 3 comma 4, I would then get 15 as the derivative. So it would be increasing very rapidly. And what we use these differential equations for usually is for these things called slope fields. And they just give us a little diagram to kind of show what an equation could possibly look like. So if we use this same formula, all we're going to do is we're going to go to each one of these points on our diagram and just kind of plug in our points and see what we get. So, for example, here at the origin, if I plug in 0 for x and 0 for y, I get 0 plus 0, which means I have a slope here of 0. I'm going to just draw a little line segment with a slope of 0. And actually, no matter what my y value is, whether it's 1, 2, negative 2, whatever, as long as x is 0, my whole slope is going to be 0. So I'm going to plug in 0 for all those. And you'll notice as you do these, you should get some patterns forming here. Another thing that we can kind of look at, let's look at 1 comma 0. So x is 1, y is 0, so I have a slope of 1. So I should have a line that looks like this. Here at negative 1, it ends up being a negative 1 slope. At 2 comma 0, it's going to be a positive 2, so a little bit more uphill. Same here. Negative 2, so a little more downhill for that one. Some of the other ones I can look at. At 1 comma 1, it would be 1 plus 1, so it should be a positive 2. Over here at negative 1, positive 1, so that means negative 1 plus negative 1, so that's negative 2. So again, a little bit more negative. And you can kind of fill in the rest as you go along. We have here would be 1 comma 2, so it would be 1 plus 2, which is 3, so a little bit more. Here it would be at 1 comma 2, it should be at 3. Here it should have been 4, and then this one ends up being 6, so it's really big. And the same over here, except they all end up being negative in these cases. So these should all be pretty steep like that as well. You can fill in on the bottom as you go along. All these end up being straight horizontal lines. Negative 1 comma negative 1 ends up being a 0. And you got zeros all around. And you can fill out the rest of these as you go. Now, once you have a finished picture, what we can look at here is what we call particular solutions. And what they're good for, let's say we want to see what the curve looks like if we started right here. Well, all we do right at this point, it looks like it's a flat line because we have flat slopes around it. But as we go away, we start going uphill in this direction. I kind of just want to follow the path of the slopes that I've already drawn. Same over here, kind of follow the path of the slopes. I don't want to cross my slopes. I want to look parallel as I go past them all. Another one I could do, if I started right here, well, it's flat line. In this case, though, it's staying flat line. So if I started at that point, 0, negative 1, it would be flat line. If I started right, so let's say up here, it looks like I would be flat and kind of the same thing, kind of up. Maybe down here, it would be kind of, flat like that, possibly. Lots of different options. It's a sketch, and it all depends on where they want us to start. Here, let's look at another example of what we can do with this. Here, x over y. So anytime x is 0, that means I'm going to have 0 over who knows what. It's still going to be 0. So when x is 0, that means I have flat lines. Now when y is 0, that means I have who knows over 0. Something divided by 0 is a vertical slope. So that means anytime I have that, I should have a vertical slope. So now what am I going to do right in here? It's tough to say. We don't know for sure. So we'll leave that as it is. Here's my other two slopes. If I draw particular solutions, I would have something maybe that looks like this if it crosses up there. Right here, maybe something that looks like that. As long as it kind of mirrors what we have for our slopes being drawn.